Hello, this is addressing a question I received that I'd like to answer for you all in class for question number 15. So here we go. This is a help for question number 15. All right, so the first one, we first need to recognize what type of curve we are working with. So we'll notice here that we are a normal curve. Also, it says Z, and when it says Z, that tells us that we are looking with that it is distributed normal with a mean of 0 and a standard deviation of 1. That's what Z implies. So it's good to know there. All right, so this one says for A, letter A, says what happens if Z, we're looking for the cutoff value, where Z is less than, this area is 0.2451. So all the area. And why did I put it over here? Let's just remember that here's 0, and 50% is going to be less than 0. So 24% has got to be somewhere over on this left tail. So from here, I'm going to grab my calculator. You can use any type of calculator or mini tab that you want to use on this. Today I'm using a TI. I'm at work, so I'm using a different calculator. I'm using a TI Inspire. You can also use Minitab, but whatever technology you're using, please avoid using a table, just because you're not going to get enough accuracy to table for MyOpenMath to work correctly. You're going to find your inverse normal under distributions. So in Minitab, it's under calculate inverse, and then you choose the normal distribution. Right? And then it's going to ask you for the area, and you're going to go ahead and put 0.2. And this is always kind of assuming the area to the left, although different calculators can sometimes give you the option of whether it's left, right, or center. But we want the left tail here, and then we're going to hit OK. And it's going to give us an answer. And this cutoff point would be negative 0.6899. And so to 2 decimal places, that's negative 0.69. So that is answer A. Moving on to B, same idea here. This time, we're going to say Z is greater than 62%. So, hey, 50% is right here at 0. So to get 62 greater, it's going to be somewhere over here. It's really nice if you're able to visualize the picture first, because then you can have a good idea, like, should my answer be negative? Should it not be negative? Now, if that's 62% here, and I want to know what area is to the left of that, right? To the left of that, that's this area over here, right? So to the left of that, I'm looking for that area. So that would be 1 minus 0.6255 of the area. So again, I'm going to calculate that. 1 minus 0.6255. And again, I'm going to go to inverse normal. I'm going to type in this area. This is the area to the left of the number that I'm looking for. And navigate to distributions and then to my inverse normal. And my area is 0.3745, and hit OK. And this number is going to be negative 0.319958. So to 2 decimal places, we would have that. Looking at our third problem here, so this is the same as problem 1. You notice that the only difference is right here, in that this one has a little line underneath it and this one doesn't. So I want you to think about a continuous distribution where you have infinitely many choices from negative infinity to infinity. What's the probability of getting a single line? It is 1 over infinity, which is, the limit of that is 0. right? If you take 1 and divide it by an infinitely large number, you can't really divide by infinity, but if, what this essentially means is the limit as x goes to infinity of 1 over x, that's going to be 0. So because that's 0, it doesn't matter if you have it less than or less than or equal to, because equal itself is just 0. So these are going to be the same probabilities in a continuous distribution. So doing problem number C is exactly the same as doing problem number A. Right? So now let's take a look at problem number D, or letter D, I should say. All right, so here we have this, and they want to know between 0 and some number up here, because it's on the upper limit, this area right here, in between here, is going to equal to 0.3554. Now my calculator, and Minitab for that matter, they are going to give me the number to the left of this. So I'm looking for the cutoff that has this 0.3555 and everything else to the left of that. Well, everything to the left of that is 0.3554 plus 50%, because left of 0 is 50, that's half of it. So that's going to be 0.8554. So I'm going to hit inverse normal in my distribution button. It's going to ask for my area. I'm going to put 0.8554. Mean is 0, standard deviation is 1. Hit enter. And that's going to give me a cutoff of 1.05987. So to 2 decimal places, 1.06. Now, I might just want to mention here for a real quick second that in the TI-84 plus, if I hit distribution and inverse normal, which is number 3, when you do that, it does have an option that says tail. And if I put that tail at center, you might think that that will give you what you want, because it has a left-right center. Center and a right. But what that would give me, if I put center, would be the 2 cutoff points that are the plus and minus centered around the 0. So if I put center and I put in 0.3554, it's not going to give me the right answer up here. It's going to give me the answer that gives me 35% of the area between these 2 points wrapped around the center of 0. So don't use that. Go ahead and do it this way up here. That's the best way to do that. Sorry if that was a little sizey. All right, let's move on to the next one. So now we are on letter. It's going to give me the answer E. All right, so this is the same idea. All right, so we're going to be at negative 2.19 up to some cutoff up here that has this area right here in between is equal to 0.8295 of the area. All right, so I want the amount of the area that is to the left of this. I need to figure that out. And in order to figure that out, I need to figure out what is this right here. All right, so I need the area. How much area is left of negative 2.99? So I have to do a 2-step issue here. The first step I have to do is I have to figure out that area, and that's going to be a normal CDF. cumulative density function. That's going to tell me how much area is underneath this curve. So I'm going to do normal CDF. Okay. I'm going to use negative infinity or -1 with a whole bunch of zeros, all the way up to -2.19. Mean is 0, standard deviation is 1. So again, on my calculator, second distribution, number 2, normal CDF. Lower limit negative, mine already has a -1 E99, which is great. That's -1 with 99 zeros after it. -2.19 for my upper, 0 and 1 for my mean and standard deviation. And this area right here is 0.01426. So to get this one now, I'm going to add these two together, plus 0.8295. And I am going to go inverse normal. Left of the area is 0.843762, 01, and hit enter. And this is going to be 1.01. 004, but that was going to round to 1.01. Okay, so that was E. Let's move on to F. So this picture says some cutoff we're looking for, and Z is between that and 1.6. So some cutoff down here that we're looking for, between that and 1.6 up here, and all that area in the middle here is 0.9101. So what I'm trying to figure out, what I need to figure out now, two questions. How much area is down here in that left tail? And then once I figure that out, then I can find that cutoff point. So to figure out how much area is in that left tail, I am going to find out how much area is all the way down from 1.6. So I'm going to go normal CDF because I'm looking for area. So distribution, normal CDX. Number 2, negative infinity, so -1 with 99 zeros after it. Upper value is 1.6. 01 for mean and standard deviation, hit enter. And the answer I get, this was is 0.9452. I'm going to take this answer minus this answer. I'm going to subtract the two and look at the difference. So that difference is, this has a little less than 3.5%, little more than 3.5% of the area down in that curve. Now that I have this area, I can use inverse normal to find this cutoff. So I'm going to go inverse normal. It's going to ask for the area. I'm going to put that area. Mean is 0, standard deviation is 1, and hit enter. Again, I'm looking at the left tail. And this is going to give me -1.81. Okay. All right, let's take a look at G. Same idea here with G. Negative. All right. First of all, we're going to use a little something that we know about this guy right here on G. Negative 6.34. Okay, this is a standard normal curve. If you remember from the empirical rule, in a standard normal curve, 68% of the data is 1 standard deviation away from the mean. And then you get 95% of the data, 2 standard deviations away from the mean. So in here is 95. And then you get 99.7, 3 standard deviations away. So I'm 6 standard deviations away. This has got infinitesimally small area after it, basically 0. So I don't really need to worry about that. I'm going to say between that and one up here that I don't know has 84%. Now, technically, I could use normal CDF and find this area down here, and then use inverse norm, subtract that area from this, or sorry, add that area to this up here, and then use inverse normal with those combined areas to get here. But the truth is, this area over here is so small that to 2 decimal places, it is going to make absolutely no difference. So I'm just going to use inverse normal and 0.8438, 0 and 1, and then find the answer. And that's going to make no difference within 2 decimal places. Now, if this isn't a negative 6.34, if your number isn't this far away from 0, let's say your number is negative 1.2, then you absolutely are going to have to use normal CDF, just like we did with the last 2 problems, and find this other area first. Add it to this area, and then do your inverse normal. So, and then our very last one is H. All right, so this says Z is less than some number, going over here, or it's greater than some number up here. And this total area, this total black area together is 0.2479. And they want to know this number here they give us. They want to know what this cutoff number is down here. But this isn't really that bad, and here I'll tell you why. Because I can find a couple different things pretty easily. First of all, I already know that this area in here is equal to 1 minus 0.2479. And how do I know that that's 0.7521 or 75.21% of the whole area? Because this has to add up to 1. These 2 things have to add up to 1 because we have 100% of the data covered. Right? So now that I know that, I also know that from here down, right, using normal CDF, if I go normal CDF, lower limit negative infinity, upper limit 2.77, that all of this data from here down is 0.997197, going from here down. That means that this area right here, this blue shaded area that I just shaded in, has to be the difference of those 2. So this shaded area right here is 0.24509. So now I'm going to use the inverse normal and find that. Right? Inverse normal. Our area is 0.24509. And I hit enter. And this number right here is negative 0.69 to 2 decimal places. Right? So that is how you do problem number 15. Thanks to the person who asked for this question. I'm going to post it this evening, and I hope you all have a great night.